I'm going to go over the review for stoichiometry. Please take out your review and take out this worksheet like this. In order to do the review or stoichiometry, you do need to see this worksheet. Please follow along. If you already know what you are doing, then you can continue and just look up when you need assistance. I'm going to start with number 1. List the coefficients of the reaction above. The coefficient is always going to be the large number in front of the element. So the coefficients for the reaction above will be 2, 3, 2, 3. You can put a little dot in between them. Number 2. Besides balancing the equation, what else do these coefficients represent? Coefficients represent the number of moles as well. That is why when you're doing the t-charts for stoichiometry, we no longer just put a 1 in front of the moles. From now on, you use the coefficients. Number 3, give the mole ratio of AlBr3 to AlCl3. Okay, so we look at the coefficient for AlBr3. You need to refer back to the equation up top. The coefficient for AlBr3 is 2. To AlCl3, which is over here, and that's 2. So it is a 2 to 2 ratio. B, Cl2, coefficient for Cl2 is 3. To AlC3, AlC3 is 2. It is a 3 to 2 ratio. Aluminum bromide to chlorine. Aluminum bromide is AlBr, so that is 2. Chlorine is right here, and the coefficient for chlorine is 3. That is a 2 to 3 ratio. Number 4. Determine if the following conversion factors are correct or incorrect. We'll start with the first one, and we do need to refer back to the original equation at the top. A mole of Cl2 is equal to a mole of Br2. Okay, this is correct. You find the Cl2 here and the Br2, and the coefficient in front of each of them is 3, which can be reduced to just 1 over 1. This one, a mole of Cl2 is equal to a gram of Br2. So now they're talking about grams, moles to grams being equal. This is incorrect. Is a mole of Cl2 equal to a gram of Cl2? Yes, because it is the same element. The last one is the grams of Cl2 equal to grams of Br2? No. Number 5, place the following in scientific notation with 2 sig figs. Scientific notation, you begin with the decimal point and you go in between the first two numerals. 1, 2, 3, 4. 2.56 times 10 to the negative 4. Because I went this way, it's a negative. B. 1, 2, 3, 4, 5, 6, 7. 2.0 times 10 to the negative 7. That is scientific notation. Number 6, mole to mole. This is stoichiometry, so you always have to check that the equation given is reduced. The equation is right here. I have 2 ALs. I have 2 ALs. I have 6 BRs. See, because it has a little 3. But I have 6 BRs here as well. And I have 6 CLs because of the little subscript here. And I have 6 CLs here as well. So after we know it's already balanced, we can begin the equation. A. How many moles of Br2 are produced when 6.5 moles of AlBr3 reacts with Cl2? Okay, before you even begin, you need to locate the first number you're given. Okay, the first number you're given will always be written on the top left-hand corner. That is what you'll start with. You always need to include this portion. It's very, very important. It tells you your next step. Not only that, it keeps you organized. If you do not start doing this on your worksheets, I will start taking off points. Not just mole, but whatever element is connected to it. You need that as well. Because if you know this is mole of AlBr3, then this has to be mole of AlBr3. These units must be the same. Okay, whatever you're looking for will be in your top right-hand box. How many moles of Br2? That's what we're looking for. It's asking us how many moles of Br2. So moles of Br2 will go there. And like I said earlier on question number 2, we no longer just put a 1 by the moles. We're going to use the coefficients. The coefficients, you will refer back to the original equation. What is the coefficient of Br2? Here's Br2. I would put a 3. What is the coefficient of AlBr3? I look at the equation up here. The coefficient for AlBr3 is 2. Anything side to side, you multiply. You'll take 6.5 times 3 in your calculator. If you got an equation like this and it has scientific notation when you're just multiplying simple numbers, you just hit this button at the top left-hand corner, second, DRG, and you use the arrow to go to flow, change the mode, and then you hit enter. You need to be comfortable with your calculator in doing that. So 6.5 times 3 equals 19.5. Then you divide what's on the bottom, which is 2. So divide it by 2, 9.75. But 9.75 what? What was I looking for? It's 9.75 moles of Br2. Okay, and all I did was 6.5 times 3, divided that number by the bottom number. Next, it's asking you how many moles of Cl2 are required to produce 4.50 moles. Okay, you really don't have to read the question at all. You need to identify what you are given. Okay? That's the number is given, and it always goes in your top left-hand box. Do not leave it like this. You need to include moles of what? Because if that's what's here, okay, then you know what's going to go down here. Moles of AlCl3. And what we are looking for goes in your top right-hand corner. How many moles of Cl2? That's what we're looking for. When it says how many, can you guys guess what goes here? It's going to be the coefficients from the original equation. So find Cl2 up top. Yep, here we go. The coefficient is 3. Next, find AlC3. Find the coefficient. Coefficient is a 2. Now you solve. You're going to get your calculator and do 4.50 times 3. Anything side by side, you multiply. That gave me 13.5, and I'm going to divide it by 2. It's 6.75. 6.75 what? What was I looking for? Moles of Cl2. Okay, we're going to start at number 7. We did moles to moles, and now we're going to do moles to grams and grams to moles. Again, this sheet will come in handy. Okay, so find this in your notes. Okay, before I even read it, I'm going to double check that this is balanced. Okay, when I say balanced, that means whatever elements are on this side have to be equal to the elements on this side. So it says I have 2 ALs. I have 6 BRs because this 2 gets multiplied by the subscript for BR. Okay, how many CLs do I have? You have 6 CLs because it gets multiplied by the subscript. Now I'm going to see over here. I have 2 ALs. This 2 is for the AL. It's for the CL2 as well, but because the CL has the 3, that means it gets multiplied by the 3. But for AL, I only have 2. For CL, it got multiplied, so now I have 6. How many BRs do I have? Hopefully you said 6. This 3 gets multiplied by the 2. So when I say balance the equation, this is what I mean. However many atoms of Cl there are have to match the other side of the equation. So what's on one side of the arrow must match on the other side of the arrow. 6Cl, 6Cl, 2Al, 2Al, 6Br, 6Brs. We now know that it is balanced. It will not always be balanced for you, so take the time to make sure it is, or else your problems you solve for will be incorrect. Before I read it, I'm just going to look at what I am given. 3.5 moles of aluminum bromide. Whatever you're given will always go in the top left-hand corner. Always, always include the unit. Do not just write 3.5. Do not just write 3.5 moles. It's very important. That's why I keep saying it. So then whatever's here goes here in this box. Okay. Whatever you are looking for is going to go in the top right-hand box. Okay, so this is my top right-hand box. I'm going to read the question. How many grams of chlorine? That's what I'm looking for. Grams of chlorine. Okay, if I'm not sure what goes in these two boxes, I'm going to refer back to this sheet. I am given moles and I'm going to grams. So I would look at this one, grams to moles. According to my notes, I'm sorry guys, I was given moles to grams. So I'm going to look at number 3, moles to grams. And according to this notes, what goes on the bottom was what I was given. I was given the ALBR3. And what goes on the top is a mole, but it's the mole of the unknown. When I say unknown, it's the mole of what you're looking for, and you can always just look in your top right-hand box, because this is what we want. This is our unknown. This is what we're looking for. So that's what goes there. And then 1 mole will go here. How do I know 1 mole goes there? I look at this chart, moles to grams, and it tells me 1 mole goes there. But these moles I have to fill in, and I can't just put a 1. I'm going to refer back to the original equation. How many moles of Cl do I have? I have 3. So I'm going to put a 3 there. How many moles of AlBr do I have? You look at the coefficient, and that's what you put right next to the mole of AlBr3, which is 2. Now to solve for this, last, I need to get the grams of chlorine. You're going to have to look at your periodic chart. To find the grams of chlorine, you're looking for the number underneath chlorine, 35.45. Whenever it says grams, you will refer to your periodic chart, okay? So I take 3.5 times 3 times 35.45, and I divide it by 2. Do the top first, 3.5 times 3 times 35.45. So that gave me 372.225. And now I'm going to divide it by 2 because that's on the bottom. 186.1. 186.1 of what? Whatever I was looking for, which was grams of chlorine. Okay, we have time for one more. Before I even read it, I'm just going to look at the number I was given. I'm going to put that in my top left. Whatever number you see goes in your top left. That's how you start the equation. 4.5 moles of chlorine. If moles of chlorine's there, moles of chlorine is here. What am I looking for? It says find the mass of bromine. By now we should know that mass means grams. So I am looking for the grams of bromine. So I was given moles and I'm going to grams. So it's the same setup as the question above, which means 1 mole goes here, and the mole of the unknown, or whatever I'm looking at, which happens to be bromine, that's the coefficient I look for. So the mole of bromine, go back to the equation at top, the mole of bromine is 3, and the mole of chlorine is 3 as well. Whatever side by side gets multiplied, you need to get the grams of bromine I do that with a periodic chart, 79.9. So I'm going to take 4.5 times 3 times 79.9. That gave me 1078.65. So 1078. But I need to divide by what's in the bottom, which is 3. My final answer is 359.5. It wanted grams of bromine. We will continue the review. We're going to finish up the chemistry test review for the stoichiometry unit. Again, this is the second half. This is what the review looks like. It says chemistry test review, stoichiometry unit. Thus far, we have gone all the way through 7B. That's where we left off. Okay. We are going to continue with 7C, which is right down here. But again, you do need to refer back to the original equation, which is up here at the top. So in order to do 7A, B, and C, you are using the original equation up here at the top that you balanced. Seven C. You can start off by just looking at the number you're given. 225 grams of Cl2. Okay, and what are they asking you to find? How many moles of aluminum chloride? So you're looking for moles of AlCl3. I know aluminum chloride is AlC3 because it told me in the question. That's why I knew. Anything you're looking for, or the unknown, what you want, goes in the top right-hand corner. Whatever you're given, the number in the problem will go on your top left-hand corner. Make sure you always write the unit and whatever element it's connected to. That is how will help you solve the problem. If grams of chlorine's there, grams of chlorine must go here. Okay? Something you guys are going to need, your periodic chart. You will also need this little T-chart here. You either wrote it in your notebook or you have one of these. So this is a grams to mole problem because it gave me grams. I'm looking for moles. I'm going to look at this chart, and this is the grams to mole setup. So it tells me on the very top I can put 1 mole, and the 2 boxes at the end say mole, mole. I'm just going to copy that exactly. In the middle it said I could put 1 mole, and then on the top and the bottom it said mole. Okay? Down here on the top will be your unknown, on the bottom will always be your known. So we know chlorine. What we didn't know was AlCl3. What numbers go here? Because this is stoichiometry, we no longer just put the number 1, we go back to the coefficients. So what's the coefficients of AlC3 at this equation? AlC3, the coefficient is 2. I'm going to put a 2 here. Look at the very top of your paper, and what's the coefficient of Cl2? The coefficient at the very top says it is 3. In order to solve this, you do 225 times 1 times 2. You can skip the times 1 because anything times 1 is itself. So 225 times 2 We forgot one box. Grams of chlorine. Where do we go to find grams of chlorine? If you're looking for the mass, you always look at the periodic chart. It's 35.4. So multiply all the top and divide it by the bottom. I'm going to multiply the bottom two, so when I do divide it, I'm dividing by just one number. So 35.4 times 3 gives me 106.2. So these two combined is 106.2. Now I'll go ahead and multiply the top. 225 times 2. That gave me 450, and I'm going to divide by the bottom, which we said was 106.2. My final answer is 4.24 moles AlCl3. I'm going to move on to D at the very bottom. I can just start off with the number they gave me. 75.5 grams of Br. What do I want? How many moles? I'm looking for moles of AlBr3. Okay, if this is grams of Br, this must be grams of Br. Okay, these two have to match. This is a grams to moles. I was given grams. I'm looking for moles. I'm going to go back to this chart. It says I just put 1 mole at the very top and the mole on the right hand side. 1 mole goes at the very top. A mole goes here. Again, all the unknowns are on the top. So AlBr is what we do not know. So down here is what was given to us, which was grams of Br. You would just put Br. Grams of Br, where do we find the mass of elements? Periodic chart. 79.9. 79.9 goes here. To find the moles of these two, you look up at the top of the worksheet and find the coefficients. What is the coefficient of AlBr3? It's 2. The coefficient of Br is 3. So I put 2 for AlBr3, 3 for Br. I'm going to multiply the top and divide it by the bottom. I personally like to multiply these just so I can divide it by one number. 79.9 times 3. These two multiplied are 239.7. I'm going to multiply the top. 75.5 times 2. That gave me 151. Okay, now I'm going to divide it by this number because that is the two bottom numbers multiplied together. 0.62. 0.63 is my final answer. Okay, let's start off at the very top. Again, I am starting off at number 8. This says it is a grams to grams. This is the equation at the top. So you will refer back to this equation for 8A and B. Let's check if it's balanced. I have 2 ALs. I have 3 BRs. Well, actually, this 2 gets multiplied by that, so I have 6 BRs. And I have 6 CLs. Over here, I have 2 ALs. 6 CLs, and 6 BRs. Step 1 is just to always make sure that it is balanced. 6 BRs, 6 CLs, 2 ALs. Now that we know it's balanced, we can begin the problem. I'm going to, before I read it, just identify what I'm given, which was 7.65 grams of ALBR3. Okay. If grams of ALBR3, what goes here? Grams of ALBR3. What am I looking for? I'm looking for grams of chlorine. Whatever you want will go on the furthermost right top corner. Grams of Cl2. That's what I'm looking for at the end. I'm going to refer back to my T-charts to figure out what I'm given. I was given grams, and I'm looking for grams. What chart am I going to copy? It's going to be this one. Because I was given grams, I'm looking for grams. So it says I can put 1 mole on top, and then the next box goes mole, mole, and then 1 mole on the bottom. So you just transpose that, you copy that to your worksheet. One mole goes on top, mole, mole goes here, and then 1 mole goes here. We do need to know moles of what, though, for these 2 boxes only. Your unknown is what goes on the top, what you're looking for. We said we were looking for Cl2. What you do already know, what you were given, goes here, which is ALBR3. Okay. Grams of Cl, where do you find the mass of chlorine? Refer back to the periodic chart, 35.4. You do not just put the number 1 by these 2 moles. Okay, instead you use the coefficient. So what is the coefficient in front of Cl2? You look at the equation, 3 is the coefficient in front of Cl2. What's the coefficient in front of ALBR3? 2. What's the grams of ALBR3? You have to look this up. Find the weight of aluminum, find the weight of bromine, but make sure you times it by 3 to get a number. So I'm looking at my periodic chart. Aluminum is 26.9. Bromine is 79.9. Except I need to multiply it by 3. So it weighs 239.7 because you have 3 of them. If your answer looks a little bit different, and if it looks like this, 2.397 times 10 to the positive 2, go ahead and change modes. Hit the second button right here, and then you hit DRG. These are the different modes your calculator can be in, and be familiar and comfortable with changing modes. Hit the arrow to the, it says flow, then you go ahead and hit enter. This is the number that you're looking for, not the scientific notation. And you can go back and forth depending what kind of problem you're given. You just hit second, DRG, use these arrows over here, hit enter for whichever one you want. So 239.7 goes there. You're going to multiply all the top, anything side by side gets multiplied, and divide it by the bottom. I like to get one number for the bottom, so I'm going to multiply those. By multiplying 239.7 times 2, I got 479.4. Now I'm going to go ahead and multiply the top. $7.65 times 3 times 35.4. For the top, you should get 812.43, and now you divide by the number on the bottom, divided by 479.4. The final answer is 1.69, what was I looking for? Grams. Grams of Cl2. Again, for B, you will have to refer back to the original equation at the top to find your coefficients to solve for. I'm not going to read the question, I'm just going to look at the number that they gave me. 15.5 grams of chlorine. If grams of chlorine's there, this has to match. This has to be grams of chlorine as well. What am I looking for? What's the unknown? What do I want? To find the mass of bromine. Mass is grams. That's what I'm looking for. I was given grams. I want grams. I go back to this chart right here. This is a grams to grams problem, so I'm going to follow this T-chart here. 1 mole goes at the top, then mole mole, and then 1 mole goes here. 1 mole, and I'm just following the chart exactly. 1 mole, it just said mole, and it just said mole there. On this top one, you put the mole of the unknown, which is Br. For the bottom one, you put the mole of what you know, which is Cl. How much does chlorine weigh? I go back to my periodic chart. 35.4. How much does bromine weigh? I go to my periodic chart. 79.9. To figure out the coefficients, you look at the very top equation. What is the coefficient for Br? You should see the number 3 in front of Br, and the coefficient for Cl, you should see a 3 in front of it. Now you can solve. Anything side by side gets multiplied, and then you divide by the bottom. Again, you can do this in your own method. I personally multiply these two first, so I can just divide by only one number. I'm going to go ahead and multiply the top. For the top, you should get 3,715.35. I'm going to divide it by the bottom, which would be these two numbers, which I already multiplied, so it gave me just one number. So I'm going to divide by 106.2. Your final answer, 34.98. What was I looking for? The mass of bromine, so grams of bromine. If your answer looks like this, and you have this times 10 to the positive 1, go ahead and hit second, DRG, go back to flow, hit enter. Calculate percent yield when a reaction yields 25.2 grams of carbon dioxide, but should have yielded 27.5 grams. Okay, for this you're going to divide your theoretical by your actual and multiply it by 100. Whenever anything says calculate a percent yield, please know that your answer will be in a percent. So your actual yield, that's for AY, it should have yielded 27.5. Okay? Your theoretical yield is going to be 25.2. So your theoretical yield, you can consider it being the experimental number. If you had an experiment and this is what you got, but you should have yielded this. This is what you actually should have gotten, okay? But instead you got this. So you divide them by 2 and multiply by 100. Okay, here's the formula. Theoretical yield, or whatever you got by experimenting, which was 25.2. Divide that by my actual yield, which was 27.5. That gives me 0.916. Multiply that by 100 to get your percent. 91.6%. Okay, again, to get the percent yield, it's going to be your theoretical yield divided by your actual yield. The actual yield is what it should be. The theoretical yield, you can consider it the experimental yield. That is what you ended up with. Actual is what it should be. Okay, let's solve for the problem below. Make sure the chemical equation they give you is balanced. I have 2 carbons over here. It looks like I only have 1 carbon, but count this carbon too. So you have 2 carbons over here as well. I have 4 hydrogens. I have 4 hydrogens on this side. And I have 2 oxygens, because this 2 goes for this oxygen as well. Okay, so you're just balancing means you're comparing both sides. So these coefficients are correct. You could just put a 1 here. In the reaction above, 125 grams of carbon was reacted with excess water. A student measured 215 grams of carbon dioxide gas was produced. So it wants the actual yield and calculate the theoretical yield of carbon dioxide. You're going to start 125 grams of carbon.